Hello students, welcome back to our Highway and Traffic Engineering lesson. We have now reached the third topic. As I have mentioned before, Highway and Traffic Engineering, my videos are exclusively for diploma students who are taking diploma in Civil Engineering. So let us begin with Chapter 3, Construction of Flexible Pavement. This topic familiarizes students to flexible pavement layers, the construction, and also the quality of work. So for part 1, we will be discussing about flexible pavement layers and materials. Now let me give you a brief introduction. Flexible pavement can be defined as the one consisting of a mixture of asphaltic or bituminous material and also the aggregates, which are placed on a bed of compacted granular material of appropriate quality in layers over the subgrade. So we have discussed the history of roads starting from Roman roads to Metcalfe, Tresagi, Telford, and finally Macadam roads. So we are now at the typical modern road, which is the flexible pavement. So as you can see, it consists of a few layers, known as the existing soils, the subbase, which is optional depending on your road design, the base course, and also the surface course, which consists of wearing course and also binder course. So flexible pavement has very low flexural strength and are flexible in their structural behavior when under a load. So this is a diagram of how a flexible pavement distributes its load towards the base, subbase, and finally the subgrade. So the main theory of a flexible pavement is that natural soil or the subgrade will be the layer that is going to bear all load from vehicles. So try to define flexible pavement in your own words. So what are the functions of a flexible pavement? The functions of a flexible pavement are as follows. Firstly, it is to provide a level of flat surface for a more comfortable and safe journey. And then it is to receive and distribute load of the vehicle to the ground layers. A flexible pavement is to protect the subgrade layers from any damage which is, of course, caused by climate changes, such as rain and drought, and sometimes in cooler countries, frost. A flexible pavement is designed to prevent seepage of water into the roadbed, which will be the layer that is going to bear every load. A flexible pavement is also designed to reduce noise that is caused from the wheels of vehicles through friction. It is also to provide high resistance to traction or skid for safety reasons, and also finally to reduce splashing of water from the wheels of the vehicles during rainy season to provide comfort for all types of road users, especially motorcyclists. So the surface layer absorbs traffic load and distributes it to the layers below until it reaches the subgrade. And this subgrade layer will be the one supporting the load, as you can see in this diagram. This is the load distribution pattern. Now, what are the characteristics of flexible pavement? The characteristics of a flexible pavement are as follows. The first one, flexible pavements are elastic, which means they are allowed to contract and also expand upon loading. Flexible pavements commonly use bitumen or asphalt, as we have mentioned or discussed in the second topic, or possibly tar, as binder materials. Note that tar is rarely used in road construction nowadays because of its toxicity properties. Maintenance work are easily done on the surface for any minor deformation, so generally a flexible pavement is easier and cheaper to maintain. And a flexible pavement does not require joints as it is constructed in a layering method. So the depth of the layers may differ according to specification and also road design. Here's a fun fact for you. Flexible pavements generally consist of at least 4 layers, additional layer for geotextiles and or other road improvements are also constructed. So do you remember the 4 layers of a flexible pavement? A flexible pavement typically is designed from the subgrade layer up to the subbase, the base, and also the wearing course. So this is a typical diagram of a flexible pavement. As you can see, it consists of firstly the natural subgrade, and then soil is compacted above the natural subgrade. Note that natural subgrade may consist of gravel or hard rocks. And then an optional layer of subbase course. And then above it is the base course, followed by the binder course and also the surface course or wearing course. This wearing course will be the first layer to receive traffic loading. So this is the material used in this layer. For surface course, we are going to use the bituminous concrete. And for the binder course is dense bituminous macadam. The base course is usually consists of wet mixed macadam. And the subbase course is usually consists of granular subbase. And finally, the natural subgrade. We have now reached part 2, the construction process of a flexible pavement. So let's begin of the subgrade layer. This is a picture of the natural soil being compacted using a roller compactor. So the materials for this layer is of course the selected soil or maybe some morum, gravel or small aggregates, which is below 50 millimeters. So after determining the maximum structural support by CBR test, CBR is California Bearing Ratio test on the soil, the subgrade is constructed by spreading the loose soil and then compacting the same soil at an optimum moisture content of the soil in the subgrade layer. If the subgrade layer is not adequately compacted, it will continue to compress, it will deform or erode after construction, and this will cause the pavement to crack and also to deform. So the key points of preparing the subgrade practices is to firstly ensure that the compacted subgrade is able to support construction traffic. And then all debris is removed. The large rocks, vegetation and also topsoil will be removed from the area which will be ready to be paved. The subgrade is then treated under the area which is to be paved with an appropriate or approved herbicide. And this is to make sure that no plantation, no roots are located at the subgrade layer. And then we move on to the construction of the subbase. The materials for this layer is crushed stone aggregates, gravel, coarse sand, and also any selected soil, which has low plasticity. The method for the construction of subbase is, the subbase is constructed on the compacted subgrade. The subbase material is spread to uniform thickness and also to reach specific cross slope. The moisture content of the material is checked, and any additional quantity of water required to bring up the optimum moisture content of the material is sprinkled uniformly. The layer is then compacted. So this is the important keys of the preparation of sub-base practices. Where sand and aggregates are combined together to meet the specified grading, care shall be taken to prevent segregation of the material into fine and coarse parts. The sub-base material containing excess moisture shall then be dried prior to or during compaction. The prepared sub-base layer shall then be protected against damage until it is covered by the base course. Speaking of base course, let's move on to the construction of base. So the materials used for the construction of base usually consist of hand-crushed aggregates, adequate proportion of water. The method is wet mixed macadam is prepared in a mixing plant. The mix is transported to the site and then spread using a self-propelled type paver finisher machine, which we commonly call the paver. Wet mixed macadam is compacted using a vibratory roller of a minimum static weight of 10 tons, and the compacted thickness is less than 200 millimeters. The late mix is then dried for at least 24 hours under the sun, so it is dried naturally. So the key points of preparation of base practices is the premixed material shall be placed on the sub-base in a uniform layer or layers not exceeding 250 millimeters in thickness before compaction. The base course material shall be placed to the required width using a self-propelled spreader or also a motor grader. The edges and edge slopes of the base course shall then be bladed or otherwise dressed to conform to the lines and dimensions to present straight, neat lines and slopes as free of loose material. So that is the construction of base using wet mixed macadam. Now we have reached the surface. We are commonly known as a bituminous macadam. So for the prime coat, the graded subgrade or the top granular base layer can be prepared with a prime coat. A prime coat is sprayed application of a cutback or asphalt emulsion bitumen applied to the surface of the untreated subgrade or base layers in order to, first of all, is to fill the surface voids, which is usually to protect the base from weather. And then it is to stabilize the fines and also preserve the base material. Lastly, it is to promote bonding to the subsequent pavement layers. That is the use of the prime coat. Now, what about the tack coat? A tack coat is a thin bituminous liquid asphalt immersion or cutback coating applied between HMA pavement lifts, which is naturally to promote bonding. Adequate bonding between construction lifts and especially between the existing road surface and an overlay is critical in order for the completed pavement structure to behave as a single unit and to provide adequate strength. Inadequate bonding between layers can result in delamination or also debonding, followed by longitudinal wheel path cracking, fatigue cracking, potholes, and other distresses such as rutting that will greatly reduce the pavement life. And finally, the last step in a construction process of a flexible pavement is leveling. So when we apply a leveling course, the first lift applied to the existing pavement is used to fill in the ruts and make up elevation differences. The top of this lift, which is relatively smooth, is then used as the base for the wearing course. Leveling course lifts need to be as thick as the deepest low spot, but not so thick that they are difficult to compact. And now for the milling processes. This is to ensure the quality of the pavement. Milling is also called grinding or cold planing. Cold planing. A top layer is milled off the existing pavement to provide a relatively smooth surface on which to pave. Milling is also commonly used to remove a distressed surface layer from an existing pavement. Milling also produces a rough, grooved surface which will increase the existing pavement surface area when compared to an ungrooved surface. So that is all for Chapter 3. Try and answer these questions. Describe the flexible pavement in your own words. Explain the preparation of materials used in the following: first, sub-base layer, subgrade layer, and also the road surface. And lastly, explain the different layers in road construction in terms of functions, in terms of thickness, and materials used for each layer. So the first is sub-base, and then base, surface, shoulders, and also the prime works involved. So try and answer these questions based on your own research and understanding of the topic. So that is all for Chapter 3. Thank you and bye-bye.